See dear, using simplex method, find the optimum solution of the LPP, and they have given the LPP. They have given the LPP. They have given here maximum z is equal to 5x plus 2y, subject to the condition 2x plus y less than or equal to 10, x plus y less than or equal to 8, our alternative x and y always greater than 0. First and foremost thing, we are going to write the equation in standard form. We are going to write the equation LPP in standard form. The meaning of standard form, first I am going to check my objective function. Our objective function is maximum z. I am going to take all the variables to one side. When I take the variables to the opposite side, this will become minus 5x minus 2y equal 0. Maximum is that minus 5x minus 2y. As I am taking all the values to one side, this will become 0. I am going to check the condition subject to the condition. Subject to the condition. I am having two conditions. The first condition is less than or equal. You have to remember, when I am having less than or equal, we are going to add a slack variable to the left hand side. We are going to add a slack variable to the left hand side. That means the idea is I am having 2x plus y. To cancel the inequality and convert the inequality into equality constraint, I am going to add a slack variable on the left hand side. Here, as this is the equation 1, I am going to take it S1 equal 10. I am going to check the next equation. The next equation is x plus y. Again, this is less than or equal to. I am going to add slack variable to the next equation. This is the equation 2. So I am going to take S2 equal 8. Don't forget all the values x, y, S1, S2. All the values are always greater than or equal 0. Always, all the values are always greater than or equal 0. This is the condition. This everybody understand this idea? This is called converting into standard form. This is called converting into standard form. From this, we are going to form the IBFS table. Everybody understand this? Shall I proceed to the next one? Okay, dear. Now, we are going to move on to the next idea here. From this standard form, we are going to write the IBFS table. We are going to form a IBFS table. The meaning of IBFS, initial, basic, feasible solution. The meaning of IBFS is nothing but initial, basic, feasible solution. In exam, if you write so small thing, that is enough. IBFS table, this is enough. But the meaning of IBFS is nothing but initial, basic, feasible solution. Now for initial, basic, feasible solution, we are going to form a table. In the table, I am going to take the table. I am going to take three, 4, 5, 6. Here on row wise, we are going to take Z, and I am going to take the newly added variables. I am having two variables which I have added newly, which are called slack variable, I am going to take these values in row. I am going to take this value in row. I'm having two variables. One is S1, one is S2. So I'm going to take S1 and S2 on the row. On column wise, we are going to take all the values. What are all the values? We have X, we have Y, we have S1, we are having S2, and we are having right hand side. We are having S2 and we are having right hand side. Here I am going to add one more. This is for finding the ratio. This is for finding the ratio. Here what we are going to do now, we are going to take the corresponding, coefficients. We are going to take the corresponding coefficients. What is the meaning of this? I am going to check what is the value of X in Z. Here the value is -5. Value of Y in Z, this is -2. I don't have any S1 value, I don't have any S2 value, there is no RHS. My RHS value is 0. I am going on to the next one. Next one is for the constraints. I am having two constraints, S1 and S2. For S1, I am going to check for the first constraint. What is the first constraint value? 2, 1, S1 is 1, there is no S2, the right hand side value is 10. In the same idea, I am going to check the second one. This is 1, 1, there is no S1, S2 value is 1, my right hand side is 8. My right hand side is 8. Now, this is called IBFS table, initial basic feasible solution table. From standard form, just we are copying the coefficient into a table. Now, the next step, from Z, I am going to find the maximum negative value. We are going to check the maximum negative value. Here I am having -5, I am having -2, 0, 0, 0. -5 is the big negative number, maximum negative number. This S is called entering variable. This S is called entering variable, EV. We call it as EV. Now I am going to find the ratio using the corresponding pivotal column elements. I am going to find the ratio using the corresponding pivotal column elements.
Doctor?
Yes, my friend.
-5 is bigger than -2?
I am talking about the maximum negative number. I am not telling about the big number. I am telling maximum negative number.
Okay.
-2 is the big number. I am not talking about this. I am talking maximum negative number. Okay. The smallest number. In the other way, you can say this is the smallest number. Now, using the corresponding pivotal column element, I am going to check the ratio. I am going to take the right hand side and I am going to divide the right hand side by the corresponding pivotal column number. I am going to take the right hand side, 10. Right hand side is 10. I am going to divide by 2. I am going to check the answer. When 10 is divided by 2, this is 5. In the same idea, I am going to check the next one. I am going to check the next one. When I check the next one, I am going to check what is the right hand side. Here the right hand side is 8. Here the right hand side is 8. I am going to divide by the corresponding number, the 1. So the answer is 8. Let me take the table to the next page. So when I check the IBFS table, first I am going to check for the entering variable where I am having the maximum negative number. So here -5 is the maximum negative number. So I am going to take X as the entering variable. Using the corresponding pivotal column element, I am going to find the ratio. To find the ratio, I am going to take the right hand side and I am going to divide by the corresponding number. When I take here, I am having 10. I am going to divide by 2. So 10 by 2 is 5. Here I am having 8. The corresponding number is 1. So 8 by 1 is 8. Now I am going to check for the least positive number, small positive number. I am going to check for the least positive number. 5 is the least positive number. 5 is the least positive number. The corresponding variable is called leaving variable. The corresponding variable is called leaving variable. What is the value here? S1 is called leaving variable. So for the first IBFS table, we formed from the constraint, we formed the IBFS table, then we found what is the entering variable, and then now we found the leaving variable. From this, we are going to find the next table, table 1. We are going to change, we are going to leave S1, we are going to enter X2 using the rule sum. Now, how to find the entering variable? We gave the kanun, we gave the rule entering variable, which is called X. X is our entering variable. To find the value of X, we said we are going to take the leaving variable and we are going to divide by the corresponding pivotal column element. We are going to divide the leaving variable. What is the leaving variable here? S1 is the leaving variable. S1 is the leaving variable. I'm going to take S1 and I'm going to divide S1 by the corresponding leaving pivotal column element. What is the corresponding pivotal column element here? 2 is the corresponding number. Let me make it big. I am going to take the given leaving variable. Here the leaving variable is S1. I am going to divide by the corresponding pivotal column element. Here when I check the corresponding pivotal column element, 2 is the corresponding pivotal column element. I am going to divide the numbers by 2. The meaning is that I am going to take the numbers and I am going to divide by 2. I am going to take the number and I am going to divide by 2. So what are all the numbers? The first number is 2. So this is 2 by 2. 2 divided by 2. What is the next one? Again, I am going to check the next number. This is 1. The next number is 1 divided by 2. The next one, again, I am going to check. This is 1 divided by 2. I am taking S1 here. I am taking the numbers from S1 and I am dividing the numbers by 2 because the pivotal column element is 2. I am going to take the next number. The next number is 0. So this is 0 divided by 2. The next number is 0. So this is 0 divided by 2. And the last number is 10. So the number will be 10 over 2. The last number is 10. The right hand side value is 10 divided by 2. Now I am going to simplify the corresponding number. I am going to check the value of X. 2 by 2, 1. 1 by 2, 0.5. 1 by 2, 0.5. 0 by 2, 0. 10 by 2, 5. So what we are going to do now? Dear, this is, I am repeating again, the number 2 is not fixed. I am going to take the corresponding pivotal column element. Here, this is the entering variable, this is the leaving variable. Where is the intersection? Where is the intersection between entering variable and leaving variable? 2. So I am taking this 2 number, the number 2. Where is the number which is intersecting between the leaving variable and the entering variable Understand the idea? 2 is not fixed. 2 is not fixed. This will change. If, for example, if the number is here minus 5 is on Y, then we will take 1. If minus 5 is on Y, then we will take 1. So this will change. Understand the idea, dear? Now using X, I am going to find the next two values. The next two values are Z and S1. To find Z, I am going to take the previous value as it is. I am going to take the previous Z as it is. What is the previous Z here? I am having -5, -2, 0, 0, 0. I am going to take the previous value as it is. Now I am going to take the opposite sign. What is the corresponding pivotal column element here? -5. I am going to take the opposite sign of the pivotal column element. I am going to take the opposite sign of pivotal column element. If I have minus, minus will become plus. If I have plus, plus will become minus. Opposite sign. And I am going to multiply the values of x. I am going to multiply the values of x, which is called entering variable, which is called entering variable. I am going to multiply, minus into minus will become plus. So here I am having 1. I am multiplying this here. I am multiplying this here. So 1 multiply 5, 5. 0 point multiplied by 5, this is 2.5. 0.5 multiplied by 5, this is 2.5. 0 multiplied by 5, this is 0. 5 multiplied by 5, this is 25. I am going to multiply the Z value with, I am going to multiply the X value, the entering variable values with opposite of entering variable, the pivotal column.
Doctor?
Yes, my friend.
Yes, you know, in X, teacher, it is too dark. If you put blue, white, blue,
Yes, no problem.
light blue, yes. Yes, thank you.
I will change it.
Yes, 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 doctor. Yes, yes.
This is okay?
Barabar, okay. Excellent.
Excellent. Okay, dear. So I'm taking X. The X value is 1, 0 0.5, 0 0.5, 0, 5. So to find the value of Z, I am going to check the corresponding pivotal column element. Here, the corresponding pivotal column element is -5. I am going to take the opposite sign. I am going to take the opposite sign, minus into minus, plus. If I have plus, I am going to take minus. If I have minus, I am going to take plus. And I am going to multiply it. I am going to multiply. In the same idea, I am going to find the value of S2. I am going to find the value of S2. But before this, I have to find the addition here. I'm going to add these two numbers. I'm going to check the answer. -5 plus 5 is 0. -2, 2.5 is 0.5. 0 plus 2.5 is 2.5. 0 plus 0 is 0. And this is 25. So the Z value for the next table is this one. The Z value for the next table is 0, 0.5, 2.5, 0, 25. Now, in the same idea, I am going to find the value of S2. I am going to take the old S2 value as it is. And then I am going to do the same idea. What we did before, I am going to do the same idea. So I am going to take S2. What is the value of S2 here? When I check, the value of S2 is 1, 1, 0, 1 and 8. 1, 1, 0, 1 and 8. I am going to check the corresponding pivotal column element. What is the corresponding pivotal column element here? 1. So I am going to take the opposite sign of this. What is the opposite sign? This will be minus of 1. And I am going to multiply with x. I am going to multiply with x. I am going to multiply with the values of x. So what will be the values of x we are having? We are having the values of x 1, 0.5, 0.5, 0 and 5. I am going to multiply by minus 1. So this will become minus 1. This will become minus 0.5. This will become minus 0.5. This will become 0. This will become minus 5. Correct dear? Understand the idea now everybody? I take the number, I take opposite sign and I am multiplying with the x value. Now I am going to find the total. I am going to find the add. I am going to add these two numbers. When I add, this is minus 1 plus 1 is 0. 1, 0.5 is 0.5. 0 minus 0.5 minus 0.5. This is 1. 8 minus 5 is 3. 8 minus 5 is 3. Now using this, I am going to form the next table. Using this, I am going to form the next table. I am going to take this table as table 1 and I am going to take the corresponding values. When we take the corresponding values, here we will have z. Z will not change. Z will not change. What is my leaving variable? S1 is leaving, X is entering. So in place of S1, I am going to take X. In place of X1, I am going to take X. And S2, I am going to keep as it is. In place of X1, I am going to take X. I am not going to make any changes in S2. I am not going to make any changes in S2. Here on the column wise, there is no change. X, Y, S1, S2, RHS. This will not change. I am going to take the corresponding number after the calculation. I am going to take the corresponding number after the calculation. What is the value of Z? The value of Z is 0, 0.5, 2.5, 0 and 1.5, isn't it now? The value of this is 0, 0.5, 2.5, this is 0, 0.5, 2.5, 0, 25, isn't it now? And then I am going to check the value of X. For X, I am having 1, 0.5, 0.5, 0, 5. For X, I am having 1, 0.5, 0.5, 0 and 5. 0 and 5. Finally, I am going to check for S2. Here is the S2 value. Here I am having 0, 0.5, minus 0.5, 1, 3. So this is I am having 0, 0.5, minus 0.5, 1, 3. I am going to check the value of Z now. Again, we are going to check the value of Z now. If I have minus value, I am going to repeat the same process again. I am going to repeat the same process again. If I don't have any minus value, our optimum solution is attained. Our optimum solution is attained. When I check here, the value of X is 0, 0.5, 2.5, 0, 25. All the numbers are plus. All the numbers are plus. That means we have reached the final solution. We have reached the final solution. So I am going to write the answer. Maximum Z equal. I am going to take the corresponding right hand side value. What is the corresponding right hand side value? 25. I am going to check the value of X and I am going to check the value of Y. Why? Because our equation, we have given X and Y. In the equation, we have given maximum Z is equal to 5X plus 2Y. I am having X and Y. So I am going to check the value of X and I am going to check the value of Y. I am going to check the right hand side of X. The right hand side of X is 5. So the value of X is 5. I am going to check for Y. There is no Y in this variable list. There is no Y in the variable list. I am having Z, I am having X, I am having S2, there is no Y, so the value of Y is 0. The value of Y is 0. So the maximum Z is 25 at X is equal to 5 and Y is equal to 0. This is the solution. This is called simplex method, finding the solution, solving LPP using simplex method. Everybody understand the idea, dear? There will be a question tomorrow in this model for 10 marks. Dear, don't expect that the students will get the same question. Each student will get different questions, so you have to be careful.
Doctor?
Yes, my son.
Yes, if you please, Doctor. You mean this question, inshallah, tomorrow come, or you will change the numbers, or what?
I will change the number. 100% I will change the number.
But the idea is same.
The idea is same. The idea is same. You will have one IBFS table. You will have the calculation and you will have table 1. That's all. You will not have 2 tables. You will have only 1 table. IBFS table. And then you will have the calculation and table 1. Yes, my friend.
Teacher, this one will be essay question or fill blank or what?
10 mark. This is for 10 mark essay question. You have to write and you have to upload the answers in the Moodle. Okay, you have to upload the answers in the Moodle. Everybody understand the idea, dear? Dear, again I am telling, I am going to check the value, the variables here. Here I am having is, dear, if the connection got disconnected, log in again. I am having Z, I am having X, I am having S2. There is no Y value. There is no Y value. As there is no Y value, I am going to take Y value 0. For example, here I am having Z, S1, Y, then the X value will be 0. Whichever the value is missing, then we will change it now. Understand the idea, Amal? Why we got Y is equal to 0? Thank you, dear. Now the connection will disconnect. Please log in again. The connection will disconnect. Please log in again.